Good morning, my students and other learners at large. Welcome to our today's lesson, which is on Introduction to Database. I'm Madam Patricia. We begin with definitions. A database is an organized collection of related data stored on a file. Then we have database management system, which is a system developed to store data in such a way that it becomes easier to retrieve, manipulate, and produce information. Mapping cardinalities. This defines the number of associations between two entities. Then we have the term entity, which is the real world object that have properties, and these properties we call them attributes. So then, what is attribute? This is a characteristic of an entity. For example, we can have an entity by the name student, and in such a example, we have now the attributes, which include the student name, ID number, gender, the course the student is taking, age, etc. Then we have a relation. Relation is just a table that is having rows and columns, and then you can use it to enter data into it. Relationship. This is a logical association amongst entities. Then we can look at others we can just look at the example of a relation. You can see that it's an example of a relation or a table. We have the attributes from the ID as student ID, student name, student age. All those are attributes. Then you can see we have a tuple. A tuple is a row. Then we have a column. Then we have characteristics of a database management system. 1. Real-world entity. In this, the DBMS architecture uses the real-world entities to be designed, and it uses the behavior and attributes too of this entity. For example, a school database can have a student as an entity, and the attributes of an entity, this entity by the name student, we have already seen in our example of the table that we have above. We have the student ID, the student name, student age, the course or class, then the session. 2, we have relation-based tables. DBMS allows entities and relations amongst themselves to form tables. A user can understand the architecture by just looking at the table names. Isolation of data and application. Database system, it's entirely different from its data. And the database is an active entity, whereas data is said to be passive, on which the database works and organizes. We also have less redundancy. whereby we know very well the DBMS follows the rules of normalization, which splits a complex relation when any of its attributes is having a redundancy in values. So this one makes it easier and reduces data repetition. Consistency. This is a state where any relation in a database remains consistent. Since there is the methods that exist, techniques which can detect attempt of leaving the database in these inconsistent states. So this one helps the designer. Query language. The DBMS is equipped with query language, which makes it more efficient to retrieve and change data. ACID properties. They stand for atomicity, consistency, isolation, and durability. So we begin with atomicity. It allows operations to be grouped into a single entity, which makes it easier when you are developing a database. Then consistency. Only allowed data must change. So the change cannot be applied to the data that has not been allowed to change. Isolation. It determines transaction integrity, which is visible to others, users. So this means if the transaction should not be visible to some users, then it is isolated from those users. Then durability. Transactions can be saved permanently in the DBMS for future use. So all this helps the database stay healthy in a multi-transactional environment. Then we have multi-user and concurrent access. The DBMS supports multi-user environment and allows them to access and manipulate data concurrently. Then we have multiple views. This one, the DBMS offers multiple views for different users. A user who is in another department will be having a different view of the database than another person in also another department. So every department will have its own features depending on what the department does. Then security. Because of multiple users or views, security must be extended, meaning the users are unable to access data that does not that they don't have right to access it. So in this, the administrator have to design the database or has to permit and also put some limits to the user so that the database can have many different levels of security features. This helps the multiple users to have different views with different features. Then we can look at the users of the DBMS, and you can see from that diagram we have three main users. We have end users, administrators, and designers. Administrators. These ones are responsible for looking at things like the usage of the database, who is supposed to access the database, what he is supposed to access, the limitations of access, is also responsible to ensure security and maintain isolation of the profile of the users, and also apply some limitations to enable the users not to access data which is not meant for them. Then they are also supposed to look for database resources such as system license. If you're supposed to buy it or renew, then also the required tools for use of that database. And also we have hardware and software and their maintenance. And we also have other components that the administrators are supposed to look for. And these components, you know them, we covered under the topic of components of DBMS. Designers, they are the ones who actually work on the designing part of the database. They keep close watch on what data should be kept and in what format. They identify and design the whole set of entities, relations, constraints, and also views. End users, these are the people who actually reap the benefits of having a DBMS. They range from the simple viewers of the database who pay attention to the logs, who was logged in, who was logged out. They also range to sophisticated users such as business analysts. DBMS architecture, we can look at the architecture of the DBMS. And this one, it can be either a single tier or a multi-tier. So in these, we have independent modules which can be independently modified, altered, or changed, or even replaced. So we can look at the architecture types. We have one tier, and in this, it's the only DBMS which can only be seen in this one tier. And in this, any changes done here will directly be done on the database management system itself, because it is the only thing or entity that directly sits on the DBMS and the user uses it. Does not provide anti-tools for the end user. Two-tier architecture. In this, we have an application through which the DBMS can be accessed from. The programmers use the two-tier where they access the DBMS by means of the application. So we have the two, the DBMS and the application. And the application layer is entirely independent of the database in terms of operation, design, and programming. Three-tier architecture. In this, we have three tiers. We have the database itself, and this one, the database resides along with its query processing language. We also have the relations that determine the data and their constraints at this level. Then we have the application tier or level, which is the middle layer. And in this, the tier resides the application server and the programs that access the database. In this, the user has to use the application tier to present an abstracted view of the database. He is unaware of the existence of the database beyond the application that he is using to access it. So he doesn't even know or even think of the database. He doesn't even see the main part of the database, but he can just access it through the application or the program. Then we have the user tier. The end user operates on this tier and they know nothing about the existence of the database beyond this layer. And at this layer, multiple views of the database can be provided by the application. So that is the database, the 3-tier architecture diagram. That is the way it looks like. We have the presentation tier, the application tier, and the database tier. You are able to see it. I think you have seen it. So thank you for being my student. I welcome you to the next lesson. And remember to subscribe if you had not subscribed. Karibu sana.